Revolutionizing the future, unleashing the power of robotics technology. Today we're embarking on a journey into the heart of innovation as we explore a realm where science fiction meets reality, the captivating world of robotics technology. Picture a future where machines seamlessly collaborate with humanity, transforming industries and pushing the boundaries of what we thought was possible. Robotics is an interdisciplinary sector of science and engineering dedicated to the design, construction, and use of mechanical robots. Our guide will give you a concrete grasp of robotics, including different types of robots and how they're being applied across industries. Do you know the meaning of the word robot? Etymologically, the term comes from the Czech word robota, meaning forced labor. It was used for the first time 100 years ago now in a play by the author of the same nationality, Karel Čapek. This play, entitled RUR, Rossum's Universal Robots, was premiered in 1921 and was a great success all over the world, leaving without knowing it a word that would last forever. To talk about the origin of robotics, we must mention Aristotle and his ideas about automated tools, Henry Ford, Leonardo da Vinci, and his mechanical knight or Isaac Asimov. Here we name the milestones that have brought real advances towards automation and autonomous mobile robotics, already in the middle of the 20th century. What exactly is robotics? Robotics is the application of science, engineering, and technology to create machines called robots that mimic or replace for human actions. Robots have always fascinated pop culture, with examples like R2-D2, the Terminator, and Wall-E. These exaggerated humanoid robot conceptions are frequently a parody of the real thing, but are they more foresighted than we realize? Robots are gaining cognitive and mechanical abilities that do not rule out the potential of an R2-D2-like machine in the future. As technology progresses, so too does the scope of what is considered robotics. In 2005, 90% of all robots could be found assembling cars in automotive factories. These robots consist mainly of mechanical arms tasked with welding or screwing on certain parts of a car. Today we're seeing an evolved and expanded definition of robotics that includes the development, creation, and use of bots that accomplish tasks like exploring the planet's harshest conditions, assisting law enforcement, streamlining surgical procedures, and undertaking rescue missions. Robotics Explained. While the world of robotics is expanding, several features of a robot remain consistent. Robots are made of some kind of mechanical structure. A robot's mechanical aspect aids it in completing duties in the environment for which it was created. For example, the Mars 2020 rover's wheels are independently powered and composed of titanium tubing, allowing it to firmly grip the red planet's tough terrain. Robots need electrical components that control and power the machinery. Essentially, an electric current, a battery for example, is needed to power a large majority of robots. Robots contain at least some level of computer programming. Without a set of code telling it what to do, a robot would just be another piece of simple machinery. Inserting a program into a robot gives it the ability to know when and how to carry out a task. We're bound to see the promise of the robotics industry sooner rather than later, as artificial intelligence and software also continue to progress. In the near future, thanks to advances in these technologies, robots will continue getting smarter, more flexible, and more energy efficient. They'll also continue to be a main focal point in smart factories, where they'll take on more difficult challenges and help to secure global supply chains. The robotics industry is filled with an admirable promise of progress that science fiction could once only dream about. From the deepest depths of our oceans to thousands of miles in outer space, robots will be found performing tasks that humans couldn't dream of achieving alone. Robotics classifications. Mechanical bots exist in a variety of shapes and sizes to do the tasks for which they are intended. The design, functioning, and degree of autonomy of all robots differ. From the 0.2 millimeter long Robo-Bee to the 200 meter long Vinskip, robots are emerging to perform tasks that humans cannot. Robots are classified into 5 types based on their skills. The types and what they do are described below. Pre-programmed robots. Pre-programmed robots operate in a controlled environment where they do simple, monotonous tasks. An example of a pre-programmed robot would be a mechanical arm on an automotive assembly line. The arm serves one function: to weld a door on, to insert a certain part into the engine, etc. And its job is to perform that task longer, faster, and more efficiently than a human. Humanoid robots. Humanoid robots are robots that look like or mimic human behavior. These robots usually perform human-like activities like running, jumping, and carrying objects, and are sometimes designed to look like us, even having human faces and expressions. 2 of the most prominent examples of humanoid robots are Hanson Robotics' Sophia and Boston Dynamics' Atlas. Autonomous robots. Autonomous robots operate independently of human operators. These robots are usually designed to carry out tasks in open environments that do not require human supervision. They are quite unique because they use sensors to perceive the world around them and then employ decision-making structures, usually a computer, to take the optimal next step based on their data and mission. One example of an autonomous robot is the Roomba vacuum cleaner, which uses sensors to roam freely throughout a home. Teleoperated robots. Teleoperated robots are semi-autonomous bots that use a wireless network to enable human control from a safe distance. These robots usually work in extreme geographical conditions, weather, and circumstances. Examples of teleoperated robots are the human-controlled submarines used to fix underwater pipe leaks during the BP oil spill, or drones used to detect landmines on a battlefield. Augmenting robots. Augmenting robots, also known as VR robots, either enhance current human capabilities or replace the capabilities a human may have lost. The field of robotics for human augmentation is a field where science fiction could become reality very soon, with bots that have the ability to redefine the definition of humanity by making humans faster and stronger. Some examples of current augmenting robots are robotic prosthetic limbs or exoskeletons used to lift hefty weights. What is a bot? What is software robotics? Software robotics, also called bots, are computer programs which carry out tasks autonomously. One common use case of software robots is a chatbot. A chatbot is a computer program that simulates conversation both online and over the phone and is often used in customer service scenarios. Chatbots can either be simple services that answer questions with an automated response or more complex digital assistants that learn from user information. Software robots only exist on the internet and originate within a computer, which means they are not considered robots. In order to be considered a robot, a device must have a physical form such as a body or a chassis. How do robots function? Independent robots. Independent robots are capable of functioning completely autonomously and independent of human operator control. These typically require more intense programming but allow robots to take the place of humans when undertaking dangerous, mundane, or otherwise impossible tasks, from bomb diffusion and deep-sea travel to factory automation. Independent robots have proven to be the most disruptive to society, as they eliminate certain jobs but also present new possibilities for growth. Dependent robots. Dependent robots are non-autonomous robots that interact with humans to enhance and supplement their already existing actions. This is a relatively new form of technology and is being constantly expanded into new applications. But one form of dependent robots that has been realized is advanced prosthetics that are controlled by the human mind. A famous example of a dependent robot was created by Johns Hopkins APL in 2018 for Johnny Matheny, a patient whose arm was amputated above the elbow. Matheny was fitted with a modular prosthetic limb so researchers could study its use over a sustained period. The MPL is controlled via electromyography, or signals sent from his amputated limb, that controls the prosthesis. Over time, Matheny became more efficient in controlling the MPL, and the signals sent from his amputated limb became smaller and less variable, leading to more accuracy in its movements and allowing Matheny to perform tasks as delicate as playing the piano. People have been pondering robots since ancient civilizations incorporated myths and beliefs of thinking machines into their societies and invented the water clock. Robotics has drastically changed since the time of the Greeks, Romans, and Egyptians, but its history is vast. And that concludes our journey through the incredible world of robotics. From the early automata of ancient times to the cutting-edge AI-powered machines of today, it's clear that the evolution of robotics has been nothing short of extraordinary. If you've been inspired by the endless possibilities of technology and innovation, don't forget to like, share, and subscribe to Innovation Explorers for more captivating explorations into the future of science and technology. Thank you for joining us on this adventure, and until next time, keep dreaming, keep innovating.